coming to the topic email spam filtering, we'll start off with explaining what's an email. Email is a digital message is just a method of digital message exchange. Email has been so popular, and as of now, most people communicate by emails. But historically, email has just started in 1970, and the initial system was just like a fax, where sender and receiver are expected to be online. But later, after some time, it developed into a better system, and both the sender and the receiver aren't needed to be online at the same time. There are many. Email is a very convenient way of communication, and in recent times there are many good providers of email platform such as Gmail, Outlook, Hotmail, Yahoo, and many more. And with every advancement in technology, there comes merits and demerits. Merits being a easy communication and a cheaper way of communicating and a faster communication. But there is a possibility of there are not exactly possibility. I mean, there is a huge possibility of misusing the email, the latest technology. So today we'll be dealing with the email spamming, the misuse of email. So any message that's delivered to a recipient which is not expected by him is called as email spam. So any unwanted message received by the recipient is stated as a spam. So there are different types of and coming to the opposite of spam is nothing but ham. It is termed as the legitimate message that a recipient user is anticipated to receive. So the spam is just an unwanted message that has been received by a user. So there are various types of spam messages. The major one would be commercial advertisement. Commercial advertisement is just like a advertisement from big large companies like Walmart, could be Publix or Home Depot. They just send out bulk messages for some kind of deal. Could be a Black Friday deal or a weekend deal or just a regular mail. But these mails aren't supposed to be like too many mails are going to just tamper the user's perspective. Like the important mails are going to be with the flooded mail system. Our important mails could be missed. So the commercial advertisements aren't expected. So we term the commercial advertisements as a spam. Coming to unsolicited advertisements, these are very treacherous advertisements. These aren't the advertisements any user had subscribed for. They were never subscribed or expected by a user. These emails are typically sent by some smaller companies which capture users' email IDs from various surveys or online polls and different various other methods, and they are not legitimate sources. Some of the examples of the unsolicited advertisements could be an ad of weight loss, which we generally see, and online education or male sex organ enhancement meals, something like that. So these are termed as severe spams, and yeah. Then coming to phishing scams are just like spoofing the mail like a mail of a bigger organization and cheating the user to uh, click the link or do an action which will lead to identity theft of the user. So phishing scam is just like a pseudo creating a pseudo copy of a bigger company and just luring the users to lose their identity. And with this identity database, hackers could do whatever they want. I mean, could do any. any illegal activities. And coming to Nigerian 419 scams, this is like very popular scam that we see in every day. Every day we see this email ID. Like he like a mail from a lawyer or someone from a faraway country stating a abandoned wealth which needs to be claimed, and request for our identity, name, email ID, address. So, and could be our bank account details, which could lead to severe problems, which with the details that we shouldn't be disclosing, it could lead to a bigger problem. And coming to Trojan horse email, Trojan horse email is just another dirty email where it just attracts a user to download an attachment and install it. And this attachment is nothing but a Trojan horse virus, which could crash your system or could open up your system to the internet, which the sender could, whatever could be the sender's intention, could be satisfied with that. And it's highly destructive to your system. And coming next to the political and terrorist spams, this is also more like a threatening the user to disclose their identity. Email spoofing could be similar to phishing scam. And then the adult content mails. So these kinds of spams will be generally in everyday life. We'll be seeing these mails, so it's not much to explain. So these spams, these are going to occupy too much space in our mailbox, and we are going to miss our important mails. So this spam is something that we should clean it up. We should clean up before it comes to our mailbox. We shouldn't be seeing that. So the so with increase in spam, initially when there were very few users, the spammers could be caught and they were penalized. But nowadays it's not so easy. It's easier to protect our system than find the culprit. So with this, there came a huge requirement for spam filtering. So all the spam filter has to filter all the trash, all the spam, and has to even it has to filter the spam and as well as the ham. Ham shouldn't be put into spam, and spam shouldn't be put into ham. If we even miss a ham, I mean a legitimate meal, it's it could be harmful, very harmful. So we require a very efficient spam filter for the problem. So for this, we propose a solution using machine learning. Machine learning algorithms are the algorithms that provide the computer with the ability to learn without giving a specific instruction. Like they would be building up on each of the data sets. With the data, it will keep on building and processing. It will build its own traits, like labeling the specific traded mails as spam and specific traded mails as hams. So in the machine learning, there are two major concepts: supervised learning and unsupervised learning. In supervised learning, we build a model. Model is like a black box where we input our email ID and comes up, and come on the other end. There comes a classification whether it's a ham or a spam. So in supervised learning, we build a model which with a with a labeled training data. So we have a data which has the expected output. So we build a model based on the expected output and the data, training data, and then use the data on the real time data set. So which is more easier and accurate actually. So some of the basic supervised learning algorithms are naive Bayes algorithm, and k nearest neighbor algorithm, and SVM, support vector machine. And coming to unsupervised learning, building a unsupervised learning builds a model on a real-time unlabeled data. So it itself will identify the features and label the data. and this cannot be accurate at all the times. It could mislead you very badly. Like it could totally switch between spam and ham if the spam were very less and ham were very huge content. There is a possibility that spam could be put in ham folder and could be put in the spam folder. So this would be our proposed system of proposed solution. So we'll be using supervised learning in our project. The basic three we'll be implementing the basic three supervised learning algorithms: naive Bayes algorithm, k nearest neighbors algorithm, and support vector machine. Then nothing but SVM. So here we will be having training set and a testing set, and then we'll process the training. We'll build our model based on the training set. Then we run the model with testing set. So we then get spam or ham. The initial in the figure there is a pre-processing normalization stage. The pre-processing normalization stage has been taken care for the UCI spam-based dataset. So we have chosen spam-based dataset, UCI spam-based dataset, which has already normalized data. So we coming to UCI spam-based. UCI spam-based is a 50. It's a 4,600. It has 4,600 instances, and each has 57 attributes, and it's a continuous spam base. Like we wouldn't find any missing attributes, or there could be few missing values, but the distribution wouldn't be so uneven. It could be linearly classified, and and taking a look at the each attribute, this contains the spam based names. So these are the names for the each attributes. So make, address, the word frequency of make, address, all, 3D, or these are the words and the frequency, and the capital letter frequency at the bottom. So these are the attributes that our UCI spam base has, and one attribute for spam and non-spam class. So with the attributes and the spam or non-spam column, we build our model and try testing it on the test data and compare the classifiers, compare their performances, and conclude over a good model which could be used. So we'll start off with naive Bayes classifier. So naive Bayes classifier runs it's a probabilistic approach to the problem. So we use probabilities in classifying whether it's a mail or it's whether a mail is a spam or ham. So coming to the equation, so for a probability that a spam is based on so we'll compute the probabilities with the training set, and then then with each test set we do the same and get the final answer. So probability that a spam is based on a given word is given by probability that a word exists in a spam message into probability that a given message is a spam by total. The bracket sums up to be a total probability that it's either a spam message or a ham message. So this we build up the values, we get the probabilities, and then with these probabilities we could always figure out whether the mail in the test data is a spam or a ham. Then we had implemented this in Python. So in a Python we had run for the 50% data. We had divided the data set 4,600 samples into two parts. One for the training and one for the testing. So initially we tried with 50% training set. So 50% as a training set and 50% as a test set. So there was 81.61% accuracy, and it executed in 0.657 seconds. Then we executed for the 30% training set, where there is it's 30% training set and rest 70% is a testing set. So then we got a accuracy of 80.62%. But with a little increase in the time, that is 0.776 seconds. Not too high, not too low, but a significant increase in the execution time. Then we took a small training set, 10% training set. Sorry. In the 10% training set, accuracy was dropped heavily to 60.87%. But execution time also increased with to almost near to 1 second. So we could summarize that 50% training set is a quite a good achieves a quite a good accuracy and a better execution time. Then coming to the next algorithm, it's k nearest neighbor algorithm. Here in the k nearest neighbor, k is nothing but the number of neighbors that we are going to compare with. So the neighbors are nothing but the training set that we feed. When in the during the training phase, we just feed the training, we just plot the training set and just store them. Whenever a new data set comes in, we just get the k number of nearest neighbors and just take a poll of what are the classification of the nearest neighbors. So if you take a look at the figure for the green dot which came up newly, for a k value of 3, for the black it corresponds to the black circle in which it one the three nearest neighbors are two red triangles and one blue square. So there are two red triangles and one blue square. So for k value of 3, we'll classify the the new data set as red triangle. But when we take k as 5, the circle becomes bigger. And here, like bigger, I mean the dotted line circle in the diagram. So right now there are two red triangles and three blue squares near to the new data set. So now there are three blue squares. So we then classify the green into the blue. So with the k value on the number of nearest neighbors, the classification will vary very much. See. So we trained with the 50% training set and we split the data set into 50% training set and 50% test set, and we plotted we ran a program for various values of k. So with k from varying from 1 to 25. So 1 to 25 there was a drop, but at 5 we got a good peak. Then it was a heavy drop, and the execution times kept on increasing. So we could kind of find as that k nearest neighbor best runs at k equal to 5, and it's a quite a effective profitable runtime. Then the next concept is support vector machine. Support vector machine, every data set will be plotted in a vector space, and a hyperplane would be built between the as a classification for the data set. So in the figure H1, H2, H5, H3. So H1 isn't a separator classifier. H2 is a separator, but the margin is too small, so we wouldn't take it as optimal one. Coming to H3, it has a good margin. It has a good distance between two classes, so we consider H3 as a classifier. And for the support vector machine, we always draw a line and then try to maximize the margins. The larger the margin, the larger the better the optimal the support vector machine is. So for the support vector machine, we use Python implementation, and we got a good result. We got a good result for 50% training set, but accuracy was 83%, but the execution time was very high, 5 seconds, like 5 seconds. But still, it is an acceptable one. So then in the conclusion, we'll compare the naive Bayes, the k-nearest, and the SVM. So with by comparing these three, we can conclude that naive Bayes approach is more better and accurate and faster too. SVM could be accurate with increasing the training set, but execution time seriously it sucks. It's very low. It's very high. It's very high. So these are the references. So now we'll go to we'll execute the program and just check the results. So we'll start off with naive Bayes classifier. So naive Bayes classifier it's completely coded in Python. So right now we are at 0.67. We took a split ratio of 0.67, and we'll just clear the screen and Python. So with a 0.67 training set, we got an 82% accuracy and a zero point 0.7 seconds. So naive Bayes classifier is working fine, and I could always change the split ratio and easily run the code. And coming to the k nearest neighbor program, we have a split ratio of zero point 0.5, and I think it's better. It takes longer time k nearest neighbor. So we'll start off with SVM. HVM, there is a scikit-learn module built in for in Python. It's a good support for machine learning. So we had used you had used the SVC module in it and used a zero point 0.5 split ratio and implemented a zero point 0.5 split ratio. So we executed SVM with 0.5 split ratio. I guess it will take like 5 seconds. See right now, so we got a 84% accuracy with 7 seconds. Now we'll go back to k nearest neighbor. K nearest neighbor takes like 120 seconds, which is like a huge amount of time. So I interrupted the previous execution and going to the last, taking it to the last. So I'll start with executing that. So the k nearest neighbor, it is programmed to run for a loop of 0 to 1. It's like programmed to run to 1 to 25 k values, not exact. So with each k, with each k, the value changes. So this execution could take like long time. Uh, we'll go back to it's better see the results. Okay, okay, okay. I'll show you the results. Hmm, the report. Okay. So results are like for the k value of 1, there is 80% accuracy, but 120-second execution time, 120 seconds of execution time. For 3, there is 80% accuracy, but 110 seconds, and for k value of 5, there is 80% accuracy and 123 seconds. The k nearest neighbor is it's not accurate and it's not feasible. It's highly not feasible. So we completely exclude the k nearest neighbor from the solution, and we just compare the Bayes classifier on the SVM. So, and final conclusion, we end with saying that naive Bayes classifier is faster. And my references were Wikipedia and the Scikit Python package, and machine learning mastery.com was very much helpful. We'll wait for some time till the first output for the nearest neighbor is out. Okay. We'll wait for it. Okay, so for the first k equal to 1, there was a 78% accuracy and a 168-second execution time. Then it will go to the, I've just programmed it to take the odd values of k, as it is a 2 class. If a, by any chance, if for k, for example, k equal to 4, if two of the neighbors are from class 1 and two other neighbors are from class 2, then we are in a screwed up situation. So that's for that reason I have taken k as odd numbers. So for the first value of k, it's 78% classification and 160. So I guess it will continue till 25, and it's going to take a long time. So we'll press a Control C and stop it here. And thank you. Thanks for watching.